Hello, friends. Welcome back to .NET API Review, where we have a big screen full of red. So a lot of people who think that they want their issues talked about today, which, yeah, sorry. Instead, let's see if we can get through, I don't know, three of them. Uh, First up, assembly.set entry assembly 101616. Do we know enough to talk about this one?
Let me check. I don't think anybody on the call can talk to that one, but I mean, we can probably still review it because it seems fairly straightforward. I think, didn't we leave some comments last time? I think we did.
Not in this issue.
Maybe I just read it and that's why it sounds familiar. I think I just might have read it. And yeah, I mean, I don't know whether Stephen has opinions on this, but like I read the issue and it seems pretty straightforward. I don't think there's anything wrong with doing that. Um, it seems like the API is in the wrong, it's in the right spot, it has the right names. We discussed the scenarios a bit. It's basically boiling down to, sometimes you have your own app models where the actual launcher is not necessarily what the user thinks of their application. So when they ask for get entry assembly later, they get quote unquote the wrong assembly. And so the idea is that in those app models, the app model can basically call set entry assembly and basically set it to the user assembly. So when they ask later, they get sensible results. Um, of course, this is still the problem that, well, it's not an entirely bulletproof abstraction. So there may be cases where we can't still lie, right? So of course you can ask for environment or process path, or you can, ask Windows what the entry point is or what the primary assembly is, right? Whatever other APIs there are, and we can't shim them all, nor do we want to. But I think for the purposes of managed code, it seems sufficient because people tend to use this for finding their own stuff, right? Finding, their own resources or stuff like that. And so they don't actually care what the module names are. They usually care about the managed pieces of it. Um, and so that seems reasonable to me.
Yeah, I mean,
So
it's
unless,
unfortunate that it's a multiple color global, but either we don't let people change it or we do. So,
well, I mean, that's kind of the problem of the app model, right? Like, I mean, the app model controls when it dispatches to user code. And then in that world, well, you make sure you set it before you dispatch to user code, right? So in which case it's fine. And then the app model is responsible for, not relying on it themselves, right?
yeah, just, I don't know, thinking of. I'll use the word malicious, but really I just mean annoying NuGet modules that somewhere along the way call set entry assembly and
I mean, that's true, right?
surprise the
Like, but
program that's hosting them later.
I mean, we have plenty of cases like that though, and I think it still comes down to like the penalty for this is just angry users, right? So like
Yeah,
and they direct their angry at whoever does surprising stuff in their new right?
yeah.
So
I mean, it's basically the same as you you changed current culture.
yeah, or
Things will happen.
change the thread scheduler or inject usings or whatever else you can do to the state of the program. Start 100 threads.
All right, first issue approved before anyone has even commented on the stream.
We are live though, right? You checked.
The button says stop streaming, which means it thinks it is streaming. So like,
Let me click on the channel. Yeah, there's something going on right
yeah, it
now.
says I have
Yeah,
12 concurrent viewers. Just nobody's chatty today.
I see my big nose and my shitty camera, so I guess that counts.
And all my gray
um,
hairs. All right, includes Swift self and Swift indirect result to represent Swift structs and enums in C sharp 100543.
So I can represent this one. So for the Swift self types, we have introduced a Swift self struct and a Swift, what was the other one? Swift error. So for each of those, they represent passing values in specific registers. This proposal proposes introducing a Swift indirect result type, which has the same aspect of saying this pointer needs to be in a particular register. And it changes the Swift self type to be generic, because for the Swift self scenario, sometimes we don't know at the projection level if the type can be passed in registers or if it needs to be passed on the stack. And if it's passed on the stack, then the pointer to that stack slot needs to be passed in the self register. So to avoid having to move duplicate a portion of the code that's in the type system and JIT layer at the projection layer, which we can't really duplicate well because it's platform specific. The suggestion is to change the type so that Swift self of T represents this type is passed in registers if possible, and otherwise a pointer to it on the stack is passed in the self register.
Jeremy, we need just to clarify, we need to know the T in order to understand if it's going to spill to the stack or if it can fit in the register. Is that basically the gist?
Yes.
Okay.
And a particular struct type could theoretically on ARM64 be passed in registers and x64 be passed on the stack.
Got it. Okay. So we really do need, we can't rely upon the opaque nature of Voidstar. We need to know the type to be able to do some more inspection.
Yes, we need to know the type because Voidstar was basically saying always pass this value in this register. Now, the one thing that I need to look at on this issue again is why we're just saying change the type instead of introducing a new type. Because I think that there is still use in saying we know this is spilled to the stack, like in the class type scenario, and in terms of the in registration, I don't know if the first register is always the self register.
I'm not entirely follow that because it looks like you just changed what was called Swift self to be called Swift indirect result.
Yes, so I'm trying to.
So that type still exists.
You effectively are adding a new type. Swift indirect result is a new type in the similar vein as the original Swift self type, but it's for a different register.
I've maybe a dumb question, but like, don't we have the exact same thing in pretty much every other platform, but we don't have these types for other platforms? So what makes Swift different here?
Swift has specific register rules for their calling convention that don't match the platform defaults. Every other interop platform that we deal with matches the platform defaults when it comes down to the calling convention. Or it has mechanisms that can already be expressed in the .NET type system to express the differences. Like when there's a particular calling convention difference on Windows for member functions with struct returns, and we were able to say, is it a struct that is not a primitive? Then that's our discriminator. But here we can't do that in the same way because the self parameter can represent many different things. It's not just the this object.
You can also look at this as a historical artifact of where .NET came from and its association with C. An argument could absolutely be made that we have a parallel stack for the C ABI or for some other ABI. This is because it does not align with our implicit ABI that we support. We need to have a little more expressiveness.
And is somebody supposed to use these in p-invoke decals or what?
Yes, so these will be used in p-invoke declarations with the callconf Swift calling convention, or in function pointer calls. This will be used by the Swift projection at the ABI at the p-invoke boundary, an unmanaged callers only boundary, to say this type needs to be passed in these correct registers.
And that's also why it's not an attribute, right? Because you can't do that in function pointers, right?
Yep.
And what are they Swift selfing? Like, is it going to
So,
be Swift self of int? I assume it would always be something that would look like a reference type.
It would be like a struct type. In particular, this is used for like calling instance members on struct types in Swift, where you can pass the this by value in the lowered form if it fits. Otherwise, it spills it to the stack and then passes a reference.
So you'd have to. So this is one of the places that you'd have to have declared the Swift type as a struct and be correct in the layout, because you're going to use that as the size computation to know if it's.
It's not just size; it's a very complex lowering algorithm,
Right.
which is why.
So you don't need size; you need shape.
You need it's shape.
Yeah.
And
So
in all
you
the
don't-
situation, in all the situations where you use this Swift self, you know that the concrete T, like you don't use this in any generic context, right?
If you were to have a concrete T, you'd also have the generic at the interop boundary, which is supported now for deletable scenarios.
Sure. I get my question is, the where T unmanaged constraint isn't going to box us into any corners if we end up in a situation where we have an unconstrained T. But I think the answer is in interop scenarios, it's always appropriately constrained or the concrete type.
Yes.
The other expectation, just for clarity here, is this is yet another source generator perspective. So like a lot of this stuff should not ideally is not leaking out into general users writing things. We can infer some of this stuff based on Swift source generators, and it's an implementation detail. How it leaks out, I don't think we have any intention of leaking this out in general, but a lot of this stuff is hopefully just implementation detail that is leveraged by the source generators.
And then, since Swift self started off as void star value and now has a T, does Swift indirect need to be T'd, or is it always going to be good at void star?
Swift indirect result always represents a pointer to the buffer to store something in.
Okay.
Swift self is the only one that it's like sometimes I put it in the register and sometimes I don't.
So the answer to your question, Jeremy, is it does not matter because it's just at the interop call and it's an implementation detail.
Okay. And then,
Ideally.
and this is a slight restatement of Steve's question about the generic constraint. All types that you would ever care to use on this are representable as a generic for Swift self. Like there would be no way that you would be Swift selfing a ref struct.
No.
Okay. And then last question for me is, I assume Swift self has not shipped in an RTM version yet.
Not in an RTM version yet. No. I will say I'm still trying to figure out, since I followed the proposal, but I didn't like immediately help contribute to the design. I don't know why we are changing Swift self, because we do have scenarios where we explicitly know it goes in there. It goes like the value goes in register and we have a pointer sized value. So I need to check one thing.
I mean, in principle, nothing prevents from having a generic and non-generic version
Yeah.
of Swift cell, right? I mean,
I was going to say procedurally, we can say that
yeah.
we're approving adding the generic one, and if the non-generic one gets pulled, that's a feature crew decision.
Okay.
And then I assume Swift indirect result by design would never have a generic, right? Because the whole point is that you don't have T.
Yeah.
That was the assertion from earlier, yeah.
Yeah, then ship it. I still don't understand though how Swift handles mutable value types then. Like, I mean, if you basically pass the struct by value, then the mutation is lost, right?
Swift doesn't have mutable struct types.
I guess that solves that problem.
Yeah, I was going to say, obviously, if you're passing it by ref, then it changes the calling convention shape.
Yeah, that's why I was wondering, because it seems like the way Jeremy described it sounded like it's an implementation detail. I'm like, well, but that kind of is important for the semantics. But if you don't have mutable structs, then yeah, nobody cares.
So not super familiar, or not very familiar with Swift at all. I see a reference in the example to a witness table in the comment. Is that like a V table or is it something else?
Yes, that's basically a V table.
Okay.
Yeah, the way that Swift implements interfaces is you pass the implementation. Their equivalent concept is a protocol, and you pass the implementation of the protocol as an additional implicit parameter.
I see.
So that's the way that they're able to support features equivalent to like our extensions proposal. It's just nothing is inherent to the object. You have to everything has to get passed along.
Alright, so I made the proposal no longer actually say it's deleting the old thing, but you're free to do that since it hasn't shipped.
Okay. Thank you.
Alright, a new attribute for interop specific struct concerns 100896.
So continuing on, this primarily came from the Swift problem as well, of Swift layout rules do not match C layout rules. So, courtesy of .NET being generally more flexible, we can handle most scenarios, but we can't handle all of the scenarios. In particular, nested, like a generic struct that has a generic field, we cannot represent correctly in .NET to match the Swift layout, and Swift enumerations we can't represent correctly in .NET in a architecture agnostic manner. So this proposal proposes a model similar to what we did for unmanaged callcon. Unmanaged callcon? What are the other ones, Aaron, that we did? Is it just that one? Is that the name of the one? Basically, provide using the last bit of a pseudo attribute enum to give us kind of an escape hatch to provide a more expansive model with the custom layout attribute, and then instead of providing a bunch of layout primitives, we are instead going to provide well-known layout models that provide a expected understood documented experience for a particular target, instead of trying to say we support like these 10 different features for layout, and you can combine them as you wish, and these specific combinations represent particular platforms. So the models we wanted to provide are C-style structs, C-style unions, Swift structs, and Swift enumerations. And then for the Swift enumeration support, we have an additional property on custom layout attribute and 2 types in the Swift namespace that provide the correct behavior for Swift enums.
Okay, I'll start with so the layout kind, I assume just somewhere between IL and the CLR itself is a 2-bit value, and you're taking the last bit to mean C other attribute.
Yep. Okay. Same thing we did with the calling convention bits, where we set calling convention unmanaged means look at an attribute, look at this particular attribute instead.
And then what is the difference between layout kind sequential and custom layout kind sequential?
They're the same, but custom layout kind sequential is better documented as this is a C-style struct layout, versus the other one is we will lay out fields in sequential order, and for the managed layout, we may or may not switch out of auto layout, switch into auto layout. Whereas this is specifically, we will do this sort of layout for this platform. Alternatively, we could name this C struct and C union in the custom layout kind to be a little bit more explicit of like, this is what we're trying to represent here.
So is something going to fail if these layout kinds are used with managed objects?
So, Aaron, what are your thoughts on that? I think that makes sense that like your type needs to be unmanaged to use the interop specific custom layout kinds.
Yeah, I would agree with that as at least a first order approximation. I would never want to see this on a, okay, it's already marked as a struct, but I would agree with that. We can relax that if we find some scenario, but.
Right, but is this going to be like a type load exception?
Yeah, it would be a type load exception.
Okay.
I mean, I think part of this design, Tanner actually kind of suggested this. I think he was one of the original people who suggested more of a language-centric approach here. That is how I would view this. This is an intentional interop scenario. I don't know if Tanner's on here, if he has any thoughts on that specifically.
What was the question? I was responding to another question on another chat.
If you wanted to comment on this direction in the design as compared to the provide multiple different knobs for layout that can be combined into, like, for example, you set these three attributes to true and you get the layout for Swift structs, as compared to a more explicit model of we support laying out in this model, in this model, in this model, and in this model.
Yeah, so I gave a longer explanation of this in the general thread, but the principle is that when .NET Framework first came out, there was a very extensible model exposed, and one of the most prominent examples of that was, for example, that you could do struct layout explicit, and then you could do non-zero field offsets, which means that you could define field offsets which did not actually match to something you could define in C or C++. And people horribly abused that, and it's caused no end of pain to this day, where people are like, oh, this is a anonymous union, so I'm just going to manually compute the field offset and put it here, and then it suddenly breaks when ARM64 support comes online. Because ARM64 has slightly different layout rules that make that those field offsets no longer correct. And in general, the recommendation for users is don't do that. You should only ever use field offset with 0. You should exactly match the underlying binary ABI layout, and that's what library import is doing internally. It's making sure that it generates blittable types that exactly match and abstract everything out from under you. And so the general premise here is that much like with function pointers, where we needed to extend the calling convention and support new things, and therefore we found a way to use one of the existing embedded bit fields to say, okay, VM, go look for this other attribute to go and figure out the real calling convention. This is kind of designed under the same principle, where we'll use one of the existing layout kind bits to basically say, go look for the actual metadata on this other attribute. The new attribute and system is extensible because it's no longer using a fixed number of embedded bits. And it kind of fixes some of those historical design problems we have. And so it's built around the concept of you really only have interop at the language level. And so you've got sequential for C, you've got union for C, you don't have the ability to manually control field layout. And when it comes to new languages we need to bring online, you have specific layouts for them as well, like Swift struct, Swift enum, and it keeps it very scoped and helps drive users towards correctness. And since most languages are based on some kind of C compatibility, this ends up being enough for almost all cases, except for the very specific edge cases like Swift, where there's a custom ABI, and the runtime is explicitly trying to avoid users needing to write C wrappers around that language, and we're trying to interop with the language explicitly ourselves. So it helps ensure correctness, helps limit and tell users exactly what we natively support and what they need to go and write C wrappers for, or another language wrapper for, to call correctly.
So I think the specific questions that we had, there were two. The first one was, I think Jeremy Barton brought this up, custom layout kind sequential and custom layout kind union. We have sequential and we're using that again. Would it make, and I think Jeremy Krasinski suggested, instead of sequential, we could say C struct and C union. So that's the first statement. And then the second statement was, during a type load, if someone has this custom layout attribute, we are assuming that the struct that it is applied to is unmanaged.
I think a slight modification on that, we'd assume that if custom layout attribute is applied to a struct and it uses one of these like interop custom layout kinds, the type would need to be unmanaged. Because we may introduce a new layout kind in the future here that may not be interop specific. Unlikely, but possible.
Sure.
Yeah,
But
I personally like the idea of calling it C struct and C union. It makes it very explicit. This is the layout of C. It also makes it very explicit that it fits into the premise of, you know, why we called it C long when we exposed that type as well. So I like that premise, and it also fits in with calling it Swift struct and Swift enum at that point. And then I don't have a particular
Oh, I'm sorry. I'm just trying to follow, and this is probably a stupid question, but how is C struct different than layout kind sequential, or custom layout kind sequential different?
So layout kind sequential and the custom layout kind C struct would mechanically be very similar. The layout kind sequential has some additional rules in terms of how it impacts the managed layout of a type, when you would have a separate managed and unmanaged layouts. Theoretically, we could choose to not offer the custom layout kind sequential or custom layout kind C struct, but I figured for completeness of saying this is a layout kind that we can use to represent well-known interop scenarios, we can just be very explicit and offer that option here as well for similar behavior.
yeah, and I mean, I think the question I was asking, slightly different but related, is, are we hooking this up to the type loader's computation of the managed layout, or is this only going to be in a library import generator change what it does thing?
this will be hooked up to the type loader.
Okay.
Because for glitable types, we don't run any sort of native layout anymore. We use the managed layout information.
Okay. So if you put custom layout kind C union on a struct and give it a field of a reference type, that's going to be a type load exception of you show me the header file that had a .NET object living in the union, you liar.
Yeah.
Okay. I'm sure C++ CLI can do it, but that doesn't count.
C++ CLI would not be using these new layout bits because they know all of their rules of how they do layout. They can do whatever they want. If they want to use explicit layout with explicit field offsets, they can do whatever they want. That compile
Yeah, I just mean I don't know if I assume C++ CLI will let you say union and then like string caret, and it's like okay.
Yeah, and then it translates it down to explicit layout with field offset 0.
Fun times.
So this is primarily for Swift. Like custom doesn't seem to like describe a lot. Like, would it be incomplete to add like a new layout kind Swift and then have Swift sub layout kind, or?
It's they only have one
only
bit
have-
left.
We've got one bit left, so if we're gonna use that bit, we should use it for a full escape hatch.
Yeah, it feels
I
like
missed that.
extended or something is better than custom, because custom sounds like there's something you can do to customize it, but you can't. It's you still have to pick one of the kinds that we provide in the box.
So this has to fit in 2
Extended.
bits. So this is going to take the value 1. Is what's going on?
No,
here?
this is the value 3.
Yeah.
Auto's the
Its
value
temper
3.
value is currently unused.
Oh,
I see.
fine.
Yeah.
One of the numbers is currently unused. Custom will be that number, and it means this other struct where you now get 2 to the 32 values.
Got it.
Now, one additional
We
question
could-
that we can go through is we have a property here on custom layout attribute that is only used by the Swift enum scenario. Do we want to instead have another attribute that if custom layout attribute says Swift enum, then we look there for that? Or are we okay with it being on here and then we could have some sort of analyzer model that, or as part of the type loader, have it make sure that you're only setting the properties that actually matter for the scenario?
And we'll pause on that and see what Tanner was trying to say.
I was just gonna comment. Potential alternative names instead of custom would be I like extended. We could call it language specific, to make it clear that that's what it's going to be. To answer Stefan's question, it's because it's one of the magic attributes that is directly embedded in IL metadata. It's not a custom attribute, so it doesn't use like the regular attribute syntax. It's actually like there's a fixed number of bits in the IL spec that exist on every single type and every single method that can be used for certain things. And in one case, that's the layout kind for a struct type.
Thank you.
Okay. As for
And then for Jeremy's,
Go ahead.
Oh, I was gonna say for Jeremy's question on whether it's on the type, I kind of like having just one attribute. Looking up many attributes is already kind of expensive for the VM, and so having just one extra attribute to look up kind of simplifies things, I think. And an analyzer would be sufficient for making sure that the right ones are being set for the right types.
Yeah, and I was gonna basically agree with that. Of if this was anything other than interop, I might care differently. But in interop, I think squeezing it is better than not. For one, we'd have to unseal the attribute. Sorry, we'd either unseal the attribute or we just now have a convention of like, oh, you need to go specify this other attribute, and that both of those have a smell to me, especially for interop. So, grab bag of
I mean-
properties it is.
I mean, like, what's wrong with having another set of attributes? Though, because the problem is not so much that it's a closed system, right? It's that maybe different attributes require specific options, right? If you say there's only one attribute, you end up in the same problem that we have today, where you have a bunch of attributes, and then, well, some of them apply to this one, some of them apply to that one, and you just have to really read the spec to figure out which ones go where, and that might not be the way you want to do this, right?
You'd need an analyzer either way, though. So we only have one bit, and that's going to say what attribute to look up, and that's going to include the attribute that includes the proper layout kind. And so we'd either have to define an attribute hierarchy of like custom layout attribute, and then Swift layout attribute and C layout attribute, and ones that are for each language, and then have to resolve all of those. In which case you're going to need an analyzer to tell users, hey, you've said the layout is Swift, but you're not using the Swift layout attribute, and so you're missing out on the properties you may need to consider.
I mean, that's
and
fair,
it
but
may end up incurring costs to the VM. So we're going to need some kind of analyzer to help direct users towards correctness either way.
I guess that's the part that I'm missing. Like, my understanding was that this is all processed by a source generator, right? Or do we expect the runtime to apply something when it loads the type?
Yeah, that was the thing I asked earlier, and it's the source generator is doing nothing here. The runtime is doing this entirely in the type loader.
I see.
And
Yeah, then you're
even
just
if
out of luck.
library import generators, one of the main sources, users are going to need to annotate their own structs to tell the source generator that it needs to interpret as a Swift struct. And then tools like ClangSharp, which also can process Swift and Objective-C bindings, will need to know how to correctly generate the attribute themselves, which means they'll have to understand all the rules around that as well. So users and tools and various code will be having to handle all of that and make sure it's correct.
Yeah, that one I think is less of a problem. I mean, you could imagine, as Jeremy said, about if custom layout attribute is an abstract class, then any source generator can just say, well, if a type is derived from this base class, and I don't understand the type, you just fail and say, sorry, it's a layout that I don't know how to process, right? So you can still make it closed and sound without having to support the world. But I think that only really works when you have, the ability to resolve types and not like cause massive perf overhead, right? Like if you expect the VM to do something on type load, then I think, the only way to make that performant is to say there's one specific type the VM looks for, and if it's not there, then you fail the load.
Yeah, and then I assume for like Swift enum, the required discriminator bits, A, mean something to somebody, and B, that the analyzer would yell at you and tell you need to set this.
Yeah.
The required discriminator bits is used as part of the layout rules, and it would look at, in particular, in the recursive layout of the struct, it would look for the Swift object and Swift bool types that are in the API proposal to determine if there's any bits inside the object it can use, along with any padding, and alternatively would append bytes at the end of the struct to make sure it has enough available bits. And then to avoid us having to do a ton of work, the proposal does not include any way to read any of this information, and it says, go call into Swift. You should be able to know where to find everything to go get the information you need.
So, one other question I have is, I believe Swift stabilized their ABI in 5. Is that right, Jeremy?
Yes.
Okay. So, not throwing any shade here. I want to be on record. I'm not throwing shade at Apple, but they make decisions sometimes. Is it important? Is it prudent to say Swift 5 enum? Because what I really would hate to say is Swift 5 is this, Swift 10 though does this other thing, and we have no discriminator for version, we have no discriminator for anything. Does that matter in this case, or is that not really interesting?
I think like if Swift introduces some sort of break, we could. So first of all, we could out there right now name it Swift 5 struct and Swift 5 enum, as Swift is still on Swift 5.10. They haven't gone to Swift 6, so we don't know. Technically, we don't know what they're going to do there. I doubt they're going to break it, as they're now telling everyone ship referencing the OS libraries that are all compiled with the Swift 5 API. And a big thing with Apple is that you can install the apps on newer versions of iOS without having to make a lot of changes.
Oh, I absolutely agree.
Yeah.
I'm just, I mean, C's as stable as it's going to get. I think Swift is still growing here in a lot of different ways. And if it does decide in some magical universe to branch off into other operating systems as a more of a first class scenario, does that change things? Do they make other decisions because they feel it's appropriate?
I think that's kind of a case similar to how one might view Objective-C or C++ or even C, where, C is pretty stable, but even C has made ABI breaking changes in the past. C++ is kind of less stable when it comes to some types, but more stable when it comes to others, and they make ABI breaking changes themselves. But for the most part, there's a core that is stable. And I think just calling it C struct, C union, Swift struct, Swift enum is probably sufficient. And then if a new version comes along in the future, we can explicitly label it Swift 6 at that time if they decide it's really appropriate to make breaking changes then.
I mean, to me, it's less about
If
the
other
breaking
operating-
changes. It's just more about the you kind of have to, like, if you want to, for example, support versioning within Swift, if you munch it all on the one custom layout type, you end up where one type has to describe multiple different ecosystems over time, right? Which is not awesome because you now have to, because enums are, you can only add at the end kind of thing. You get this overlapping, nightmare kind of thing, right?
Yeah, Alexei, I don't know if people saw in the issue, or if anybody how far has read through it, but Alexei actually had something very similar to this, and I think he was advocating for one of the original initial designs, where it's a series of features. I'm not entirely convinced that's a good idea, but it does speak to the complexity that we're getting at, especially with the versioning thing, as opposed to creating a series of features that are supported. The downside is, I think Tanner clarified this pretty well, which is if you have a series of features, then you have this complex matrix of, well, this doesn't work with this and this doesn't work with that. It just becomes a mess. So I think this is the right approach, but I do have a little bit of concern about supporting Swift as a first class enum and then it doing something subtly different.
Yeah, I mean,
the other way it could be handled is so we have C struct, C union. If there comes a point where that's broken in the future, we already have the required discriminator bits feature. We can just add an ABI version field, which for Swift happens to default to 5, and users can override it to a future one if that's appropriate. And that's basically the same thing.
So basically, on the custom layout attribute would have an implied API number. Is that what you're getting at?
Yeah, there's an implied ABI number today. If it changes in the future, and we're hopeful that it never does, we can expose that, and then users can override it to an explicit one that's different from the default.
I'm sold. That makes sense to me, because I don't like it in the name, but I do want to have it. I would like to have the option someplace. I think that makes sense.
Yeah, I think if it came up, while the loader would understand if you say Swift struct or Swift enum and didn't set the thing, it means 5. I think we would make the analyzer say, you said Swift struct, you need to tell me which version you meant.
Yeah, we could make it say, you got to tell me your version, and here's a code fix that puts the default explicitly.
Again, so we have a roll forward functional behavior, but that going forward, it's like, don't just leave this dangling for Swift, because presumably once there's a ABI, 6, 10, whatever it ends up being, that presumably new things would all want to set it, and so this is really just helping you with, like, did you really mean to call something from back in the 2020s? Yep.
Yeah.
I can
And
speak
think
from the
that
future.
I think having that model would be useful, as there are other languages that also have, for example, Rust has this model called epochs that allows them to, or epic, whatever the phrasing is, I don't remember, but that's versioned based on a year, so that they can avoid breaking ABI by saying you can always build for a particular year's ABI. So if we were to ever add first-class Rust support, having being able to use that sort of model would be useful, depending on what changes they make where. I don't know how much of that is ABI level and how much of that is just their standard library level.
Okay, so
Do we not have anything for Android, by the way?
For Android, we don't have anything, as Java interop is still being investigated on how we would do it outside, and at the ABI level, to use Java to enter the Java ecosystem, you have to go through Seed, through their JNI layer. So it's not like Swift, where you have a native symbol you can call, and it just uses a completely different calling convention.
But I guess my Uber question is more whatever we do there, we are kind of convinced either the existing interrupt stuff is servicing that, or the new custom layout kind would work for them as well. What I would really hate is if we approve this, we go ahead with this, and then a year from now we're like, oh yeah, actually that doesn't quite work for them. For Android, we need something else for that.
As long as Android is continuing to be a Java platform, and as long as they're a Java platform, that's the first thing, and their version of Java adheres in spirit to the JVM's specification, C will be handled. If they do something crazy, yes, you're absolutely right, but that would be a pretty large shift, stepping away from the current JVM spec and moving away from Java in general.
And I think the other key thing here is that, for the most part, if you can interop with a language, then you can always use C. Even for Swift, you can use C sequential and C union. You just have to go through the official C interop ABIs. Just like for Objective-C, you have to go and call obs, send message, and those things to actually call the Objective-C APIs. The whole reason that the Swift struct and Swift enum are here is because the runtime wants to bypass the normal C wrapper layer and interop directly with Swift for perf reasons. Java doesn't have that capability today because, much like .NET, they don't define a stable ABI at all. So if you want to interop with .NET, you have to go through the runtime functions to get a C compatible function pointer, and then languages can call that. And Java's basically the same way because of the way their runtime works. So I don't think we could add a custom layout kind Java here in the future. But if we did, and we were to limit and scope it, then we would be able to use an additional property like the required discriminator bits or like a potential future ABI version property to help direct things like, say, this is Java interop for Android 20. That would just be a lot of long-term work and support in the runtime to do.
All right, I'll hold all of you legally accountable in a year from now when we have this conversation.
All right, so we mentioned renaming custom. So I took the sample and renamed custom to extended to see how we feel about that. We can also reshape some other names through here.
The other option that I had thought of was language or language specific, since that's kind of what it implies here.
I'd prefer to keep it as extended, as we may add like new layout options on here that aren't necessarily language specific. Like if we were to ever add control for alignment, like for over aligned types, we would put it on this same attribute because we can't put it on struct layout. So that's why I was thinking extended is a better option there.
Should the attribute be called extended layout and the layout kind be language, since the layout kind is going to say C struct, C union, Swift struct, Swift enum, but then the attribute has extended metadata which might not be language specific?
I mean, I think that the core layout kind, the last bit name, should very heavily coincide with the attribute name.
Yeah.
Like, the only difference might be we think that we need to put struct layout here to be clear that this is extending struct layout. But then you get extended struct layout, extended struct layout. So.
Yeah, so what I was saying is you'd have struct layout kind extended, then you'd have the extended layout attribute. But instead of extended layout kind, layout or language kind, or language layout kind, since that's indicating it's a language specific layout.
Is there an easy way in the VM for us to determine which constructor was used for the custom attribute? Because if we were to want to add something like the over-aligned option, we wouldn't want to put that on a language specific. We'd want to have some other constructor.
So how that works is you actually custom layout lookup, custom attribute lookup is done through the constructor. That's actually how it works. We go to the constructor and then we say from the constructor, what constructor is this type a part of? So that is technically how we do it. But this is more than likely going to be one of those special attribute lookups that we do, because as Tanner mentioned, looking up lots of attributes is expensive, especially on type load. So what this will typically do is we have a fast path for that. And in that path, we just know it's this type. There is an optimized path for that. But in general, we do the hops through constructor. Constructor goes to what type, and then we actually ask more questions.
Okay. So yeah, so we could.
I didn't think that. Go ahead.
I was gonna say, so then that means we would be able to understand. We could have a language-specific constructor, and then we could have, if we wanted to introduce extended things for .NET layout, we could we could have a second constructor that describes the .NET layout semantics for whatever our new scenario is there.
I mean, I don't know how you would make that language specific though. Like, I mean, you kind of have a factory method, right? So how do you know that this is the Swift constructor versus the .NET constructor?
The constructor is written out in the metadata. Enough of the constructor signature is written out in the metadata. So
no, I meant more like
can
the parameter shape. Like, what is what? Because if you just take a layout kind, then why is it Swift specific?
On extended struct layout, we'd have we'd have like a language specific layout kind constructor on the extended layout attribute type, and then we'd have a second one.
Oh, I see what you're saying. So you have different types.
Yeah. So we kind of have different categories of the layout. One is like, this is for like interacting with other languages. If you're using this, your type must be unmanaged. And then the other one would be like, these are new ways to lay out .NET types for possibly better performance on a particular platform, given the types of the fields, things like that. Or this is for some other thing. That's the only scenario I can really think of.
I would think that in either case, we don't want to have a number of constructors here. This is the kind of case where I think we just want one constructor, and then we have the properties, and users set the properties, and the analyzer tells them if they're setting them wrong. And if we end up adding support for managed layout customizations, then I think we would just want to add to language layout kind a managed entry, or call it .NET, or something like that. And then you would say extended layout kind managed, comma, align equals 16.
Okay.
Yeah, I agree with Tanner. That's kind of the design you want, because otherwise with constructors you end up very quickly in, you know, how many overloads do you want, and like what is optional and what's not optional, right? Like that gets very tricky to model, and then eventually you end up in a world where you have properties anyway, and then it's probably better to just say, like, you know, you just have the kind and then everything else is properties. And then whatever combinations are valid is then the analyzer's job to figure out and tell you, the users, that they're holding it wrong. I think you still have, of course, the goal that I guess that the analyzer should be able to tell what you're trying to achieve. But at that point, well, it's fine if it's an enum member, because then, you know, you said Swift, I don't know, whatever. And then it's like, okay, now the Swift forever rules are kicking in, and you need to set these properties, but not these ones, and blah, blah, blah.
Okay. Yeah, the idea of having like the language specify like .NET or .NET or managed, I think satisfies my concerns.
Yeah, I mean, I don't see why we need to say language in here at all.
No, you don't. I think
it would just be extended layout kind, or yeah, if we call it like extended layout attribute, it's extended layout kind. And
I actually like that. It's very similar.
It pairs well with what we already have. And
Yep, that's fair. I had just suggested language as maybe a clarifier on exactly what that particular enum member meant, but it was not a strong preference, and I like extended layout kind as well.
Yeah.
And so then I guess, so we seem happy with layout kind extended. I have two things on screen: extended layout and extended struct layout. Do we care?
I would prefer extended layout with attribute target struct, because if we ever were to extend it to classes, I really don't like how we have struct layout for class types.
Fair enough.
And I would prefer we don't continue that on the new type.
Yeah, I mean, I will point
Yeah,
out that
I mean,
we could
I
also
kind of
name it that,
agree.
except our naming guidelines say don't.
I kind of agree with that, like what Jeremy just said. The only thing that I don't like is that it seems you always have to pair them up. right? Because you always have to apply struct layout anyways in order to say it's extended. At which point, I think the aligning of the names just seems more desirable. Like if you could get away with never having to say struct
What-
layout, then I think it makes sense to say, hey, on classes, I don't want to see struct. But even in class, you still have struct layout extended, and then you have to say extended layout. So I might as well say extended struct layout, right?
So we could get away with not. There's basically two ways we could do that. One is that the language already has built-in understanding of struct layout. It already may require some changes to make sure it understands extended. In which case we could just have the language output struct layout kind extended when it sees extended layout.
I see.
Or we already have the library import source generator that's always running anyways.
Yeah, we could add another source.
We could
generator.
just have it generate.
Can you qualify one thing? Because I was under the impression that we wouldn't have to change the language compilers if we just do what's on the screen right now. So why would we have to do any changes to the compiler?
Roslyn may validate.
I don't think changes.
Yeah, we believe Roslyn validates the layout kind value that's passed into struct layout to make sure it's one of the ones it knows of. So
I
it may
see.
have
So
to
just
either remove that validation or understand extended is also valid.
Gotcha. Yeah. Well, if we have to touch the compiler, then yeah, I agree with Tanner. Then it makes sense to say, why do you have to say both of them if you can just say one of them? That makes more sense to me.
I will point out the notion of saying we'll just make the source generator do it, etc. For one, I think means you would have to declare your struct as partial, and for two, we can say that we can easily say C# will hide this for you, but if you are writing these in F#, you're still going to have to specify both unless F# also takes a language change.
Well,
So-
I mean, as Jeremy said, like it seems like you have to change the language no matter what, right? Because I don't know what F# does today, but if they also enforce that layout kind is one of the two it knows, then you have to touch it anyways to support extended.
Right. It depends on if they checked that it's that you only have, or that you have no more than 2-bit set, or if they checked that it's only one of the 3 well-known
Right.
words, or if they did nothing.
I would say my care level for languages that don't support the source generator is going down significantly because it seems like for those you have to do something else anyway, like that. So it's hard for me to imagine what the
Sorry,
F# solution
I'm just saying
looks like anyway.
there will be worlds where you will still have to specify /C both of them. And if you look on like docs, if any of these are on a public
Sure.
type, it'll show both of them because that's the way we manifest documentation. And
Well, I mean, again, it depends on what we say, right? So like it's reasonable to say that the compiler says you either say struct layout or you say extended layout, right? And then if you say extended layout, it implies struct layout extended, but you don't get to say it in source, right? At
right,
which point
but
it's like you'd never see them together.
But things like, I mean, you could change your APIs of .NET to say don't manifest the layout bit if you see extended struct layout, but the docs generator, etc. is like
Well-
we'd have to go change it to tell it don't show both of these at the same time. The default
mean-
would be you'd show both of them.
Well, the problem is that struct layout is not an actual attribute, so it's encoded completely differently.
Yeah.
So like everybody has to do special work today to promote these pseudo attributes to custom attributes.
Yeah.
And so I think in practice it means we have to do work probably no matter what. I think
Fair enough.
at the minimum you would have to map the bits, right, to say that means layout kind dot extended, right? So but I think I don't know, like I mean my general feeling is like if we have to touch the compiler to make it sound, well then I would just go with the simpler model and say you don't get to say it in C#, at which point that becomes more or less our blueprint for how we would do it in other languages if we get to control it. At which point it makes sense for me to drop the struct, right? Because it does seem weird to apply something called struct to a class.
And it looks like right now the language errors with invalid value for argument to struct layout attribute if you do layout kind, if you cast 1 to layout kind. It doesn't fail if you cast 2. but then it's of course not clear if they're failing because they know because one's not defined in the actual layout kind enum, or because they've explicitly blocked it. So it's going to require talking to the language team either way to figure out whether they actually need a change.
Yeah, I think I would say if we don't have to touch the compilers at all, I would probably align the names. If we have to touch the compilers, I would make it so you don't need to say the old name.
I think I agree with Immo, especially because this also adds in some protection around a very annoying case we'd have to check, which we'll still check in the runtime, but it's nicer to not have to write an analyzer to handle it. That struct layout has a number of customization options on it, which we don't want to allow in this new system. So we don't have to go and be like, oh, you set struct layout pack or struct layout size when using extended layout. Don't do that. We don't allow that.
I mean, that depends on where you want to do this, right? I think it makes sense to say that's the kind of stuff you handle in the analyzer, because then you have one place to handle it all. I mean, we could push it to the compiler, but then you would have to talk to the compiler team about understanding extended layout, which you may not want. I think you probably want to live in a world where the compiler has very limited knowledge about extended layout and everything lives in the source generator, than to say, oh, the compiler has to handle half the error messages, because then, first of all, changing that is going to be a pain in the butt. And then the other problem is I am not sure what that's a general downside when you have to touch the compiler. Like, it would be nice if it didn't have to touch the compiler, because it means you have a safe or like an easier way to do down targeting with it, right? As soon as you have to rely on the language to handle it, then you kind of constrain where you can use these things to begin with.
Yeah. I just mean, like, if the compiler says, oh, I see extended layout, I will omit the layout kind extended bit. You don't have to write struct layout. It could even say you can't write struct layout.
Yeah, sorry, yeah. Yeah, if that's the minimum thing you have, then I think that makes probably the most sense.
Right. Because to me, I think this is okay. Not great. This is better. And I don't like that.
I mean, you say you don't like that, but I think in source generators, that's more or less the world.
No. But I'm saying we shouldn't depend on the source generator for I'll write struct layout for you. I mean, it could be a feature that if you didn't specify, if the compiler's not going to automatically apply it for some reason, then we could do it in a source generator, but I think that the source generator shouldn't yell at you if you supply it yourself, because I think it's weird if you're like, well, what's partial about this type? Oh, I used extended struct layout. That means it's going to go splat some other attributes on it for me. It's like, that's just bananas.
It's actually, and you're absolutely right, Jeremy. I fully agree with you. The worst part that from an interop perspective of that partial is I wrote that type. If another source generator starts adding fields to that, as no bueno. Do not touch.
Yeah.
Partial structs should not exist, but we are where we are.
My recollection is the C# compiler says only one partial is allowed to add a field. Once a field's declared, the other partials are only allowed to add methods.
Right. But it does breed the idea of a partial struct is just not good from an interop perspective. It's very confusing, and I don't think it's a good idea. So I agree with you.
Yeah.
We should avoid it if possible.
Well, I mean, I think that the canonical example where people use partial is to just add methods, right? Which in general seems fine.
Sure.
But I understand the concerns for like a type on the interop boundary, where it's like this is very specifically matching the shape of a type in another ecosystem. Like, just give me the raw data and make a wrapper around it that has a nice .NET API surface if you want.
I mean, sure, but that's also not what we've always done, right? Very often we just end up with the one type definition, right?
I mean, especially when it comes to interop, the answer is ask 5 people and you'll get 11 opinions. So.
Well, yeah, that's true too. But like, I don't know. I don't think there's anything particularly wrong with partial. I would just say the problem with partial is if you have the shape of the type lives in multiple places, that's bad. But that's
right.
Not necessarily,
Yeah, I'm just saying I don't think that we should design the experience around this, around the notion of
I agree.
that you should always declare your types as partial with extended layout, and that the source generator will slap the other attribute on you. The compiler, I'm totally fine with doing it, but
Yeah.
but it seems weird if we say this is the only way you can write it.
No, that's very fair. I would agree with that. I don't think the source generator should paint over that.
Right. Okay, so we don't want struct, we just want extended layout, and we're hoping that the compiler will let this be our happy shape.
Yes. And if that is not possible, then I would rename it to extended struct layout. If you have to say both.
And then in your
Also,
opinion is...
it is worth noting that the language.
Go ahead, Tanner.
I was going to say the language does allow partial structs with fields, just like it allows partial classes with fields. It does emit a warning for structs with fields, but the way the language works there is it does it in compilation order. So if you pass file 1 and file 2, the fields are sequential in the order of file 1 as they appear in file 1, file 2. That also impacts things like static constructor initializers, which is why getting the compiler to be deterministic was a big thing a while back, because otherwise MS Build could implicitly switch the order the files were passed in based on the file system enumeration order, which then caused your static constructor execution order to change.
Well, that's why other languages that are better designed than C# have a file order.
You mean that's why other systems other than MS Build have a file order?
No, I mean, F# does support MS Build. It's just a concept in the project system that you can order files.
Fair enough. Yes, I'm not a fan of the auto globbing.
I don't mind auto globbing. I just think auto globbing combined with whatever the order is, we feel like it is probably a bad idea.
Yeah, I thought I saw a compile failure. It's possible that in .NET Runtime we have that warning set as error, because I feel like I hit it in a project I was working on, where it was I needed an extra field in an OS variant of a type, and then made it.
I mean, in fairness, unless you do something that involves interop, like the order of the fields in many cases doesn't matter, right? So like it's nice if you can contribute fields in other partials, but yeah, it does have this problem of, oh well, no, the order is whatever the fucking file order is.
Yep. Okay. So I think we discussed separate attributes. Alright, so we say required discriminator bits is just going to live on extended layout, and it only makes sense for one of these kinds, and we'll just, at some point we may regret this decision, but hopefully we don't. But I think it'd be weird if we then start any of the models where we start introducing extra attributes on top of this. I think just start getting really sad really fast. As opposed to this, which gets sad slowly. Alright, so Swift object and Swift bool.
So for the Swift enum and allocating discriminator bits, Swift has a concept of using spare bits, so bits that are unused, for pointers to Swift objects, and the bool type in Swift. The Swift objects, the specific number of bits and which bits are considered spare depends on the architecture. And Swift bool, it's always only using the bottom bit. So the idea is these types would be recognized by the layout algorithm as, okay, I'm representing an object coming from Swift. So I can use these particular bits, and then the managed definition of Swift object would mask off those bits when getting the value. And then similarly for Swift bool.
And so spare in the sense of Swift means that the address or real address will have been a 0.
Yeah, so like the top, I think it's like the top 24 bits in Swift object and the bottom 3 or the bottom 2 because of alignment.
Mhm.
Basically, it says you can use these for discriminator bits if necessary. So when allocating discriminator bits for the enum, it can be like, okay, I'll use the top 2 bits of this 64-bit block because I will only ever have a Swift object here. So I know these top bits will never be set by anything.
Right. Just making sure that it's not that you're supposed to clear them and then OR them with a system pointer mask or whatever, like that.
Yeah.
That like, oh, there's never anything semantic in the top 4 bits, but they're not always 0.
Yeah. So that's the basic idea for Swift object and Swift bool. And I checked the Swift standard library, which is the only place that is physically possible to describe types that have spare bits. And Swift bool is the only type in the standard library. They removed all the other cases before stabilizing the ABI.
And Swift calls the type bool, ends at the L, no EAN.
Yep.
Do we have other bools in our universe? As in, do we always spell it Boolean, or have we ever truncated it?
In the interop space on unmanaged type, we have bool.
Alright, good enough for me.
Are these effectively transparent structs where the runtime's basically going to treat them as the underlying void star or bool field?
If that was necessary, yes. I don't believe there is a scenario where these types would need to be treated specially as their underlying types due to just when they would be used. And like in the interop scenario, it's not going to call the value and pass that down. It's going to pass down the stored data.
And does Swift object have a use outside Swift struct and Swift enumeration packing?
It could be used throughout the projection to represent Swift objects, but it doesn't necessarily have to be. It just needs to be used in the Swift struct and Swift enum scenarios to get the layout correct.
And so if you have a Swift enum, and so you have, I assume it's like a C enum that you say multiple fields and only one of them is actually true. Somewhere in that enum type is, like, do you have one in your example?
Yeah, I think I have. Yeah. I don't think I have the Swift type there, but we could have. I have the example somewhere. I think it's farther down in the proposal. I have the actual Swift types.
Because this is when somebody writes one of these enums, how do they know what they can use? Because my recollection is a Swift enum is what C calls a union.
A Swift enum is it's a tagged union effectively, or it's more like a discriminated union model where you can have entries that can have data and entries that don't have data. Otherwise, I can just based on the example, I can write up the sample, and I can write up an example and send it out in.
Yeah, I mean, I'm just wondering when somebody writes one of these things, how they know which values are callable.
So the idea is you'd have to go down to, you'd have to get the value witness table from Swift, and go call the method to get the tag there, and then you can use that to figure out which payload to grab, or call the get tags payload method, which is also on there.
Okay.
Yeah, this is basically the idea is that we're doing the absolute minimum ABI support. We're not adding in the nice APIs for like reading the discriminator bits, and that way we can avoid some of the logic, some of the messiest logic.
Okay, so you're going to let somebody declare a Swift enum, but then they're going to have to jump through a few hoops if they need to work with it. Presumably including if they need to set one, like build one locally and pass it into Swift, because they'll have to have set the discriminator, which there's no way to do.
Yeah, you'd have to always go down to the Swift the value witness table for the enum type and always call the methods on that to do the work. Basically, we're only representing layout.
Okay, so there's just some runtime function they'd have to p-invoke into to do things.
Yeah, or they'd have to get the function pointer and then call the function pointer while passing this in using the Swift self type from the previous scenario.
Okay.
So I sent a link for the Godbolt link that shows the example of the two types here. So the generated assembly just has the class type because I didn't write anything that uses the enums. But these are the enum shapes that match the examples in the proposal.
And I guess somebody who needs to use this would know what to do with this.
Yes. The idea is that Swift projection can use if you scroll all the way to the bottom, or if you search, you can find value witness table 4. If you search for that, you'll see.
Because there's a lot of them. But...
Yeah. Well, yeah. These are all the entries. The tables are towards the bottom, and they basically just have entries for all of the function pointers.
Fair enough.
So the idea is this is well defined in the Swift API, and this is how the stable API, even the non-frozen scenarios work. Of you have to pull the value witness table to get any information about layout, because layout may depend on runtime information. So we can just say you have to go this route for reading information out of an enum.
Fair enough. I assume if it gets popular, you'll make it easier.
Yeah, if it gets popular outside of the Swift projection scenario, which I doubt, because the Swift projection scenario should be able to handle all of this. This is basically just for the case of these types need to be passed as parameters by value with frozen ABI. So we need to actually have the real layout.
Yeah. And then you may have said it, but how's somebody supposed to know what value to pass for required discriminator bits?
you can pull it from the API information for how many cases you have in the enum.
So there's something you can do in Swift and ask the question, and it will tell you what you needed to have written here.
Yes.
Okay. And are these structs for Swift object and Swift bool? Are they? I guess declaring a property like this means they have a field, which means they're not definite assignment candidates. So okay, I was gonna ask: do we need to declare them as having a private field so that they're not able to just be accidentally assigned? Accidentally
For the-
constructed. But I think that they get one because use the auto property. So an auto property will have a backing field, which means it's no longer able to be definite assigned.
We can also put the property in there, and I think when I do the ref assembly, I'll have to because of the way that we.
Yeah. In my head, it was I read this just as being empty for some reason. So that was just me being stupid. All right. Any other feedback? Oh, I guess we said C struct and C union. Now that it's written down this way, does anyone want to barf? Cool.
I just want my donut clause. That's all.
You want a donut?
He put in the chat, in quotes, Jeremy, Aaron, and Tanner promised that Android will just work. If that's not the case, they promise to buy donuts for the entire .NET team.
Gotcha. You non-hosting people with your secret chats. All right. We have 20 minutes left. And we have exhausted the agenda, so...
Steven had a few.
Yeah, I have
Then
some
you
that
drop-
should be pretty
oh, yeah.
quick.
Okay.
That update generated regex one. So we have the generated regex attribute, which you can only put on methods today. There's a 90% chance that in C# 13 they will land support for partial properties, at which point it also makes sense to be able to put this onto a property. And so this is just adding attribute targets property to the attribute.
What are the semantics of this if you don't provide a
Exactly the same as it is for a method. It's just without the parentheses.
so basically it means the call is omitted?
No, it's exactly the same as what you get with generated regex today, which is that the source generator provides a partial implementation that fills in the method. So you declare your partial method today, and it without a body, and it creates a partial with a body. The exact same thing would happen here. You declare your partial property without an implementation, and the source generator provides the implementation.
Yeah, I mean, more like for methods, isn't the semantics if you say partial some method and then nobody provides the partial, it just means calls to the partial are erased, right?
No.
Not if you have a visibility modifier on it.
Or a return type, or a return value.
I see.
You're thinking old partial void.
Oh, interesting. I didn't realize there was a difference between visibility and non-visibility. I guess visibility implies that you want this to be.
It's really the return.
Yeah.
It's really the return that does it. Gives you that.
Right. But you can't if you explicitly specify visibility. I think that also
Yeah,
makes it a required partial.
Agreed. Yes.
I assume your generator is going to get angry if somebody's get set.
Yep.
Okay.
The what I currently have implemented, it requires it to be an auto prop that's get only.
Yep.
And it's already the case with the method stuff that you could put it up the attribute on any method, but then the source generator issues diagnostics to say, oh, you have the wrong return type, or you've provided a body, or this isn't partial, or whatever.
Right.
We'll have the same set of conditions on properties.
And if we said no here for some reason, somebody would still be able to put it on the get in this case, right? Or partial property is going to work in a weird way that would not make that work.
That won't work.
Okay.
The source generator won't know what to do with that because it right now it only knows how to provide an implementation for a method, and I don't know what it would even look like to have a. I don't know what this would look like in that case.
Fair enough.
But it would not work today.
I know that the language will allow it because the get there is a method. If your generator would say I'm confused, then that's fine.
Could you just have a method that the property get returns?
Yeah, you can.
Okay, you can do that. Yeah. Okay.
Yeah, the main benefit to this is, besides being able to remove two parentheses, is if you're doing multi-targeting, it's kind of annoying today because the generator doesn't work for Net Standard or for NetFX because it's part of the .NET Core ref pack. So you have to do this weird dance where you're like, if .NET Core else framework, and for .NET Core you have to write a method, but for .NET Framework you really just want a field. So like cache a static read-only field, cache your regex. But you have to, if you're going to then consume that elsewhere, you want the same surface area exposed. So then for .NET Framework you also have to write this little wrapper method that delegates to the field. With properties, if each of them becomes a one-liner, because with the property you can just have it assigned to, you can say regex my prop2 get equals new regex. It just makes it a little bit nicer.
Fair enough. And then I assume you're only going to ship it if the
Yeah.
if the language feature lands.
Yeah.
Yeah.
And not only lands, but lands in runtime with enough time for us to then, push it out. But I'm told by Jared that it should be there soon.
Extension anything's next version, 5 versions ago.
All right, and then next one should also be really fast. The add collection builders for frozen collection types. It's like 92190. It's near the bottom of your screen. Yeah, that one. In the last release, we added create methods and attributes on collections to say that you can then basically create methods that you can call explicitly to say I want to create this thing, and then also an attribute that allows the compiler to use collection expressions to create it. We neglect to do so for frozen collections for a variety of reasons. We still don't have the means to do it for dictionary yet, but we can do it for frozen set. We've gotten several requests for it. So this is just replicating the exact same create pattern that exists elsewhere in system collections immutable. It's the exact same set of overloads, for example, on immutable hash set, immutable sorted set, and then adding the same attribute onto frozen set to say, if you want to initialize a frozen set with a collection expression, these are the APIs to go use.
And the reason we don't do it for dictionaries is because the language has no expression for that yet, right?
Correct. Yeah, the dictionary expressions are still in the works. So when that lands, we'll then have to go revisit all of our dictionaries to see what we need to expose for those.
Can the new syntax call the create that takes the equality comparer, or is that just once you have the
No.
create, you're making a API parity.
Correct.
Okay.
Right now, you can do this. There's an API to frozen set. It's an extension method. It's meant to be used like I have a set and I want to convert it to a frozen set. You can use that, but it's not obvious. So this create method is just makes that easier and provides parity with the immutable sets, which do the same thing. They have two immutable hash set and create. So this is just adding the equivalent.
Should we at least add the create methods for the dictionary, or would you want to wait for those?
I prefer to wait just because it'd be nice to be able to have them of the right shape that the builder will use, and I don't know what that shape is yet.
Right.
Or to know enough that we won't want to use it. But regardless, I'd like more information before we burn
fair
the
enough.
bridge.
And it already works for all built-in collection types, right? Except for dictionaries, right?
Yeah, and it works for dictionaries if it's an empty initializer, but not if you actually have anything in it. You can make it work with dictionaries if you use the key value pairs as the entries, but yeah, that's
Right.
it's not the nice syntax. But yeah, the rest of our collection types all work fine because collection expressions work for anything that worked with collection initializers. So it was pretty much only the immutable collections that needed something special because you can't mutate them once they're created.
And I read only set works today as well, and it gives you back a hash set presumably.
It does. An iSet and iReadOnly set are the two interfaces of our standard interfaces that don't work. It's the compiler that provides implementations for iList, iEnumerable, iCollection, iReadOnly collection, iReadOnly list, etc.
I see.
It doesn't today for iSet, read-only set. We could do so. We'd have to figure out. I was hesitant to do so because I wasn't sure, what the exact semantics that people wanted were. But people have tried to have suggested that I'm being too nervous about it and it should just be hash set. And so we can do it. We just need to figure out if we want the implementation to live in the library or in the compiler.
Yeah, I'm fine either way, to be honest. I mean, yeah. I'm still not entirely sure. Like, I mean, they still haven't made var work, right? So it seems like maybe we should wait until they have that because it might, influence what they want to pick as the natural type for
Right.
those things. But I guess var collection expression would only ever bind to something that is, array-like. So you probably never get a set out of it.
It's most likely going to be span, list, array, some combination of this. Anyhow.
I guess for dictionaries, you could have different semantics if the language syntax would allow you to express the difference meaningfully.
Or I could just stay
Yeah.
not compiling. That's good too.
Yeah, I don't think it's going to fly. There's a lot of feedback on this. They're going to do something in this space, would be my guess.
But yeah, for the issue at hand, it seems right to me.
Yep, I think it seems fine.
All right. There are a couple more we could look at. They're not quite as simple,
Locking.
but still pretty simple.
Oh.
So I would say either the last red one, the overload resolution priority attribute, probably have a long discussion about naming there, or read-only set of T, 3 from the bottom.
Yeah, Fred asked me to get it scheduled. I mean, if we just approve it, I don't think he's going to object to that. He just asked to get it done before his vacation next week, so I asked whether Tuesday would work, and he said yes. But I'm okay with talking about it now.
I mean,
So
do we think it's actually a 10-minute issue?
it's entirely about naming.
Okay.
So the Aaron, we're not deciding anything about overload resolution rules, just naming, because otherwise, this would be 3 days. So the compiler's adding a feature that allows you to put an attribute on members of a method group and dictate, if it would otherwise be ambiguous, effectively how you'd like the compiler to prioritize the overloads, or even if it's not ambiguous, if one would have otherwise won, you can kind of fix that. So for the canonical example here is the moment this works, we'll use it on debug.assert, because today we have debug.assert that takes a string, and we have debug.assert that takes 2 strings. And we'd really like to put caller argument expression on that second string, such that if you just write debug assert some condition, when the assert fails, rather than getting a meaningless message, you at least get to see what the expression was. But we can't do that today because the single string overload will always win. But once we have this, we can put this onto the 2-parameter overload along with the caller argument expression and say, no, this one should win. And then the compiler will prefer to use it. So that feature is in the works. It's about to land. It needs this attribute that is user exposed so that you can put this on your methods to say, you know, the priority. The priority is just an arbitrary int32 where by default all methods have a value of 0, and then you can specify some higher priority or lower priority. Higher number is higher, lower priority is lower. It just needs a name.
Yeah, and I talked with Fred, and this also should, when we had the string values has 2 implicit conversion operators debacle, if we picked one of those and said it was a better conversion operator, or one of them said it was a worse conversion operator, that also would have solved our param span problem. I mean, really, it's our string values problem, but yeah, so he says it should also work on UDCs. Or at least that he'll want to make it work on UDCs.
Yeah.
Yeah, so the only numbers I've ever seen are 0 and 1. So 1 mean, I guess you showed it here on span. So 1 is pick me, and -1 is avoid me unless the compile would fail.
Right.
And then technically there are extremes beyond that, but presumably that's just so you get 4 billion versioning mistakes.
Say that again.
No one should write overload resolution priority 2 until they've already taken 1, and they later have a like, no, really, I mean this one's better.
I haven't thought through all the combinations. I'm assuming the minds of Jared and Fred could come up with situations where different overlapping sets of overloads would be choosable in different situations.
And
in which case
so,
you might want to have different priorities to disambiguate those different groups.
Can this promote an extension method over a instance method?
I believe we decided no.
Okay. This is just
so
making sure
the
we understand
way,
it for naming. So, go ahead, Tanner.
The way that the feature was described to me, and I understood it, is that this just impacts each group. So today there's effectively groups of like, first the language looks at instance methods. If it cannot find an instance method that's compatible, then it goes and looks at extension methods. And extension methods it looks at based on distance from the place you're calling it. So if you've got something that's 1 namespace away, if you've got 2 classes with extensions, each one being 1 namespace away, they're part of the same extension overload group. But they're not included with ones that are 2 namespaces away. And so if you have someone providing, if you've got system link and you've got someone else providing something like system.myBetterLink, they could go and mark their myBetterLink with -1 and take precedence over our own link where previously it would have been an ambiguity. And then you can theoretically get into a versioning war between those 2 groups where they're like, no, I'm better, until they both equal, you know, the highest value, and then you can't change it anymore. But in practice, people shouldn't be doing that. They should only be using it for overloading within their own group definition. And so really it should only be like 0, 1, and -1.
My understanding from the LDM notes is that they decided that it really truly is within the type. So even if you have two extension methods on different types that are the same distance, first the compiler will pick which type has the best overload, and then within that type, this attribute starts taking precedence. So it really is like the last step.
And presumably we expect very few, if anybody, really using this, right? This is really meant as when everything else fails, you use this to tweak the experience, right?
Yeah, I think every release we have one or two cases where we would want to apply this, and eventually we bubbled up enough to add this. So it's a pretty rare thing, but when you need it, you need it.
Yeah, I'm asking more for the namespace because I think
And
we generally treat this namespace as this is used by the compiler, not by humans. So generally speaking, we don't put attributes there that we expect people to apply. I think it's probably fair to say if we only expect this to be a super, super tiny case, then putting it in compiler services probably makes sense. But it is a bit of a grab bag, and for the most part, it's just for language syntax that is lowered, not by humans.
It is pretty niche.
Yeah. Sorry, Tanner?
I think it's a similar level of nicheness to interpolated string handler, which is also in compiler services.
Right.
Yeah, because
Yeah, that's yeah.
for us, I think, debug assert is the obvious place we would use it. We would probably walk up to the string values type and say that the string array one is preferred over the string one. If we actually add the span conversion, which I think we approved it, but nobody's done the work yet, then maybe we would just say prefer the span one. But anyway, I think we only have a dozen places that we would use it, and hopefully no one else would. It's really something new came in the future and made you wish that you could undo a previous feature, like color argument expression. That's
So
what
there's
came,
never-
not what we want to do.
There's never a case you'd want to do this for an extension method in a different assembly. Or something like that. So we're fine with the same class restriction.
I think if you don't have that, you get into a giant war.
Yeah.
Of people
I-
modifying other
maybe.
people's types, it's
I mean, I think that's probably an overblown concern, right? Perhaps, but
really
you could
challenge
you
accepted.
don't. I mean, nothing's stopping me from creating an assembly that straight up conflicts. I mean, but maybe I'm wrong.
Yeah, you just define your own thing in a namespace called system that is a extension method on object called toString, and you give it overload resolution priority int.max value. All right.
Yeah. I
Now
mean, someone's
everyone
gonna
has a
do
bad
it.
day. So
All right. But are people actually going to use libraries that do it? Yeah, probably.
I own a lot of libraries. Of course, Steve code reviews them, so he might not let me do it.
Yeah, no, I understand the caution. I was just.
Yeah, I mean it
And-
describes what it does, and
And Stevens, the other question I had is how do they think about this on the language committee? Do they think of this as a C# specific thing, or is this something that we would say other languages, if they want to support it, they can as tiebreakers, but we don't really have an expectation that they all follow the same rules.
I think the hope is that eventually other languages would take it into account. I believe it's in the plans for F# too, though I don't know if that will land, this release. I suspect VB will not be updated.
Right.
And this is only used at compile time. There's no runtime semantics here.
Correct. And in particular, there are no plans to go and update the dynamic binder from Microsoft C#.
Right. So this is also something that we would just trim out during the trimming step.
We
We
could.
could trim it. Yeah, okay.
Well, you could during the application build. We can't
Right.
when
yeah,
building a
okay.
library.
I think the name seems fine. I mean, it describes what it does. It's an expert level API. Seems reasonable to me.
Is this strictly a tiebreaker?
Not strictly. Like in the debug assert example, it's not a tie today.
Okay.
Yeah, I'm sure this is going to make the overload resolution chapter of the C# spec a very fun read.
Presumably, we are okay with changing priorities, right?
And the other,
Is that fair? Like, if we fuck up the number and then we want to insert something there, we could, right?
Yes.
Yeah.
As long as I think within whatever breaking change, whatever we consider a breaking change, right? So we'll change which overload of debug assert code when it recompiles binds to, and that will have a minor impact on behavior, but for the better. And so, it have a behavioral impact. So we can make those kinds of changes, and it would be up to us to we would want to avoid cases where it made a behavioral change that caused significant problems. But I think the extreme case is the one that Levi was tossing around is, would we consider putting this onto string.indexOf to say, oh, you called string.indexOf with a string. What you meant was string.indexOf with a string and a string comparison.ordinal, which would allow us to keep existing binaries working the way they currently are with culture-aware indexOf, but recompiling would shift it over to being ordinal. That's a longer discussion of whether we'd want to use it for that.
Well, clearly we add a string property to this, and then there's a compat flag. You can opt out from the compiler, right?
So does this work with default values and stuff like that? Or so like, can I
Yes.
prefer something with more arguments and default values? Okay.
Yeah, that's the assert case.
Yeah.
Okay.
Yeah. So interestingly, I thought when I talked to Fred.
that I did ask.
Go ahead, Tanner.
I was going to say one of the things that I did confirm with Fred is that this doesn't allow you to overload in ways that the language doesn't allow you to overload today. So, for example, you cannot deprioritize a method and then introduce a new method that only differs by return type. That is still not allowed now, although it could theoretically be allowed in the future. And so it's important to note that this isn't this isn't the same as the original proposal of, fully pulling an API from the compiler, resolving it, showing IntelliSense and anything like that. This is purely just like it impacts lookup, but doesn't allow like ambiguities that the compiler would otherwise block on.
In other words, it's not quite what Jared's feature was, right? Jared had this binary compat attribute, which basically did what you just said. It removes it from the candidate set, right?
Yeah.
Yeah, I thought when I talked to Fred, the exact match was still gonna win, but if Fred's the one who wrote this issue, he clearly disagrees with that. / I didn't understand it, but yeah, I mean, I get the language will do what the language does. We just have to decide the name, and I think the name's right.
Yeah, I mean, it's important to know a little. Like, if it actually was just a tiebreaker, putting like tiebreaker in there might be helpful, but it's not. So yeah, I think it's fine.
Yeah, my only concern was about the priority, but it seems like by the same token that allows us to add the attribute to an existing method, we can also change the priorities if there is a need for that. So it's fine. And all the decisions are always local to the type, so.
Yeah, and it won't make an invalid. Yeah, so it'll never make an invalid thing become valid / tell you compile error. You missed a required argument. It'll just be I could have called these two things instead of whatever the normal rules were for who wins, or to say this is ambiguous, you need a cast operator. It'll say, oh, there's a unique thing at a higher priority, so it wins. I assume there's all sorts of shooting yourself in the foot by slapping overload resolution priority 1 on both of these. I don't know if the fact that this was originally better would still be better, or you're going to kill yourself, and I don't think we care.
So what are the rules for an existing method? The priority is assumed to be 0, right?
Yeah, every method is assumed to be 0 by default.
I mean, it works as you would expect. I mean, it seems. I mean, expect maybe a strong word for overall resolution, but it seems within the, the normal semantics of these things.
And then the usage, it needs to be on property because of indexers.
I believe that's the case.
Okay. I was assuming there's not a separate attribute target for indexers, then I assume that's there for indexers. Because otherwise, when are you going to have overloaded properties? But
I gotta run. Thank you.
thank you. And yeah. All right. Congratulations, Fred. You got your issue approved without showing up. Yeah, that's totally what I did. There we go. Alrighty. We got through a lot more than the 3 we hoped. So cool, but we're still quite a lot of things in the backlog. So, Emo, we are meeting on Thursday, right?
We are, and Thursday is ML.
Yeah.
Tokenizers.
Yep. So we're at
What's
high level of meetings now.
what's
I know
the
you were-
plan for next week since it's build?
I would say depending on how bad it is, we either do it or we cancel. But like we usually have had meetings during conferences because it's more for us, and the meeting is streamed. So if people show up, we usually tell them, hey, if you're watching this video right now, you're doing it wrong. You should probably watch this build. But for us who don't attend build, you might as well review stuff, right? And then the video is available on demand for people to watch it afterwards. Righty.
All right.
And I see you guys on Thursday.
Ciao.
See ya.
So
Bye bye.
thanks everyone for joining us. As you probably heard, we will be having another review meeting on Thursday for something to do with ML. I don't think it's marked already, but we will be here on Thursday, 10 a.m. Redmond time. So that'll be here at our same .NET time on our same .NET channel. And if you miss Thursday, we'll see you on Tuesday unless we cancel because it's build. Auf Wiedersehen.